much of the historic nature of the school was very much founded on a strong emphasis on fluid power.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, you can follow us on Twitter. You'll find us there at the NFPA. And make sure to share interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is actually one of the ways that we source topics for our show. If you see an interesting or innovative application of fluid power, and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on all the podcatching services, Apple Podcasts, Spotify, wherever you find us, please subscribe and then go ahead and give us a rating. Those ratings really do help more of our friends in the industry hear about the show and join in on these important conversations. On today's show, our guests are Doctors Luis Rodriguez and Daniel Williams. Luis is an assistant professor and Daniel is an associate professor, both of mechanical engineering and both at the Milwaukee School of Engineering. And we invited them into our forum today to learn more about what MSOE is doing as one of NFPA's power partner universities to get its students involved in fluid power education and careers. Luis and Daniel, welcome to Fluid Power Forum.
Well, thank you for the invitation. It's a pleasure to be here today.
Yes, thank you, Eric.
We're glad to have you both on the podcast. For our regular listeners, you know that every few episodes or so, we like to kind of get some educators on the show with us. We are all about innovative and interesting applications and advances in fluid power technology. And that's going to happen in the future through the students that you guys interact with and teach on a regular basis. So we're happy to have some time to dig into that a little bit, learn a little bit more about what's going on at MSOE. But first off, let's tell our listeners a little bit more about yourselves. Luis, why don't you start? What's your background? How'd you find yourself working at MSOE?
Well, I'm an assistant professor, as you mentioned, in the mechanical engineering department here at MSOE. I obtained my bachelor's degree from UC San Diego. I also obtained a master's degree from UW-Madison, and I also hold a PhD from University of California, Irvine. All my degrees are in mechanical engineering. So after completing my PhD, originally I had planned to finally enter the industry and finally start making some money. But after talking with my advisor, he actually asked me a very interesting question that kind of changed my career path in a way. The question that he asked me was what kind of product I would be interested in developing as an engineer. At the time, I gave him a pretty rushed answer. And honestly, I can't even remember the answer that I gave my advisor at the time. However, that day I went home and I really thought about that question very deeply. And the more I thought about it, the more I came into the realization that an engineer, for instance, at a car company, works there because they want to design vehicles, and it's the product that they work on and they develop. I, on the other hand, wanted to help develop a different type of product. So as an educator, I want to really help develop the next generation of problem solvers and innovators. So students, I believe, are my product, and I want to see them succeed. And the reason that I want to see them succeed is because I hope that they would be able to elevate the communities they come from as they become successful. So this is really why I decided to pursue a career in academia.
That's a great story, and what a noble purpose in a lot of ways. You know, it's as I said in the intro, the product, as you just said, are the students that are going to help drive the technology of the future. So kudos and congratulations. That's great. Daniel,
Thank you.
Daniel, what about you? What's your background? How'd you come into your position there at MSOE?
Well, I went to graduate school hoping to develop a deeper understanding of engineering in general, and I really was engaged as I got on in that to enjoying understanding engineering problems more and more. But by the time I finished my PhD, which was at University of Wisconsin-Madison, um, I was starting to realize that I really wanted to go into teaching long term, but having no exposure to engineers, I had no relatives that were engineers, and I hadn't been around it, in a small town, I hadn't been around any big companies.
Mm-hmm.
I really wanted to go into industry first and get some really good experience in the engineering profession, because I didn't think that I was really prepared to tell students about real engineering just based on my schooling. So I went at that point, I went to John Deere and worked at John Deere Construction and Forestry in Dubuque, Iowa, where they have a lot of fluid power applications, and they're very interesting ones too. So I really enjoyed my time there. I was there for 18 years. That was longer than my original career plan,
Wow.
but I wanted to look for a teaching university, one that focused on undergraduate education as opposed to a research university, because I really wanted to be involved directly with the students and less so with guiding research projects. So that's kind of, there aren't a lot of schools like MSOE around the country, and MSOE is one of the foremost ones in my mind. So I was very glad to get here and be able to teach students with an eye towards the experiences I had.
Yeah, that's one of the things I was going to ask about as well. And either one of you, I guess, can respond here. I mean, to tell us a little bit more about MSOE as a school. As you said, it's a unique kind of environment when you compare it to a lot of more research-based universities, as you just said, Dan. So, how would you describe, what MSOE's purpose or main emphasis is as an engineering school?
Yeah, Eric, it's got a long history of being a very practical oriented school, and it's small. It's in the mid two to 3,000 range, probably like a 2,500. I don't know the exact numbers. It's private, and it's non-sectarian. So it was created in 1903, I believe it was, by people that just wanted to advance the field of engineering. It's predominantly an engineering school, as the name indicates, but it also has business and nursing and a growing a number of other science-related majors. But about a quarter of the school is mechanical engineering students. So even though it's a fairly small school, it's a fairly large mechanical engineering department, which I think is a great strength for our field.
And not only that, from a fluid power perspective, the emphasis on fluid power is more prevalent, I think, at MSOE than at a lot of other schools. Do you find that to be the case?
In fact, much of the historic nature of the school was very much founded on a strong emphasis on fluid power.
I know you have some unique fluid power resources, teaching resources on campus. Maybe you guys can describe that a little bit for our listeners.
Yeah, we have a relatively new lab funded in large part by NFPA funds, and we use it for our automatic controls laboratory, which basically covers 100% of our mechanical engineering students as it's a required class. And so they don't do all fluid power experiments in there, but they do have some good hands-on exposure, because the lab setup is can be configured to drive a rotational system, and it also can be configured to drive a translating hydraulic cylinder system. So we have a couple experiments in position control and an experiment in motor speed control, which are really good hands-on exposures for the automatic control students. And in the process, they get introduced to fluid power. So it's a great lab for that. It's relatively new as a lab, so it hasn't been expanded to impact our fluid power elective yet, but that'll change in the next year or so.
Yeah. I mentioned in the opening that MSOE has been designated a Power Partner University by NFPA, and that is a program that recognizes universities for excellence in fluid power education. There's a list of requirements that a school needs to engage in order to qualify for that program, one of which is teaching the fluid power competencies that have been identified by our industry members. as those being most essential for entry-level fluid power engineers that they're looking to hire. And it's those labs and those other resources that you've just described where a lot of that activity can take place. So there are other requirements for that Power Partner University. Maybe we can go through some of them, and Luis or Dan, you can describe a little bit more tactically what those mean on your campus. One is you need to have a fluid power club on campus. What is a fluid power club?
Yes, so the Fluid Power Club at MSOE, we founded the club about 3 years ago, and really the purpose of the club is to provide students the opportunity to learn about the fluid power industry, and also to give them students the opportunity to experience hands-on projects where they can learn about fluid power components. Since the lab has been created, we have been able to bring numerous speakers on campus from various different industries, from pneumatics and also hydraulic industries. So some of the representatives have come from Force America, for instance, Husco, SMC, Milwaukee Cylinder, and GS Global Resources, to name a few.
Those are all great NFPA members located in and around the Milwaukee area. So that's great.
Yes, and the NFPA has been fantastic at helping us obtain these speakers to come onto campus.
Well, one of the things that NFPA is interested in with regard to that club is it extends down into the underclassmen as well. The freshmen and the sophomores, right? So, getting in front of those students early on in their academic careers is really key to introducing them to and getting them excited about fluid power.
Absolutely, because typically students really get excited about working with projects, and this gives them kind of an opportunity to really get their hands dirty in working with a project. And we have a couple of activities that we're planning with the club. One of the club activities that we have been planning is to create some sort of a portable educational hydraulic cart where students will have like a 2-gallon per minute pump the students can use to start putting fluid power components together so that they can start visualizing the fluid power hydraulic circuits. And we envision that in the future, the students will be able to create some sort of a go-kart, which is something I think really fun to look forward to. A second activity that we're thinking, and this is kind of fairly new activity that we have been thinking about, is actually collaborating with the NFPA and MSOE and Society of Hispanic Professional Engineers at MSOE to create actually a club activity to help engage women and students from underrepresented communities.
Sure, yeah.
So the idea is to use these fluid power education activities to engage and inform these students towards, perhaps pursuing a STEM-related field such as fluid power.
That's exciting. Yeah, that's great. There is an untapped potential, if you will, for a lot of those communities that you just described to move into STEM careers in general, but certainly engineering and fluid power would be a great focus.
Yeah, so one of the things that we're thinking, so not too long ago, I saw a micro excavator just browsing online, and it really caught my eye, because it was, they had the joysticks and it really looked like an excavator, but it was a miniature excavator.
Yeah.
And the more I looked at it, I realized that Purdue University developed it in 2009. So I got really excited about that, and I wanted to replicate this micro excavator so that we can perhaps be able to bring it to schools and trying to get students engaged.
That's great.
So we've been in contact with Jose Garcia, and he's been really helpful in providing us different technical information and bill of materials for different components. So that's something that we're planning on pursuing.
That's great to hear, Luis. And I didn't know about that before getting on the show today. So If memory serves, that project was also funded through a grant from NFPA, and the intent was to share that knowledge around. So it's great that Jose is connecting with you, and hopefully we'll see that replicated at MSOE. So that's fantastic. I know another activity that it falls under the Power Partner structure that you guys recently participated in was what we call a student connection event. Describe for us what that is and what purpose that you see that serving.
Yes, so the Student Industry Connection event. So at MSOE, we called it the Fluid Power Networking event.
Mm-hmm.
But it took place in September of this year. So it was the first time that MSOE hosted the event. So the goals of the event were to first provide students opportunity to network with fluid power industry representatives. Second, to spark student interest and awareness in fluid power careers. And we also wanted students to learn about internships, co-ops, and full-time positions. Yeah. So it was a great event. It also exposed students to fluid power applications and products. So the event took place, and in my view, it was a complete success. So we had approximately 10 fluid power companies attend the event, and we had approximately 80 participants attending the event. So the participants range in majors from mechanical to industrial engineering, electrical engineering, computer science. And so since then, I've heard some feedback from both students and industry representatives, and overall the feedback has been very, very, very good.
Yeah.
A lot of the students have been thankful for having the event at MSOE. I have also heard of students being selected for interviews.
That's great.
From those companies that attended the event, and from industry representatives, we have heard that they were really impressed with our students at MSOE. They found them really, really engaging, and they said that they asked a lot of questions and seemed very interested, really interested in the products and the companies in attendance.
Well, there's no doubt. I had the pleasure of attending that event as well, and there was a real energy as you experienced and as you just described in the room with all those connections taking place. And it was very gratifying to see that happen, because that's continually one of the challenges that our industry faces is the educated students that they need to hire are out there, but how do they make connections to them? And that's what this event is really designed to do. So, and as a power partner, it's the kind of thing that you guys will be doing annually, right? At least regular events in this space.
Yes, it'd be great. I think we had an amazing experience, and we look forward to doing it again.
A third requirement that we can talk about for being a Power Partner University is participation in NFPA's Fluid Power Vehicle Challenge. And I know that MSOE has only been doing that for 2 or 3 years, if I remember correctly, but tell us a little bit about what that program is and what students can experience there.
Yeah, so the competition essentially requires students to design and build a human-powered vehicle. So yes, we have been participating since the NFPA took over the event, but we have also participated in the past when originally Parker Hannafin hosted the Chainless Challenge.
Right.
Back then, Tim Kerrigan, who's now the director of Fluid Power Institute, served as an advisor. Also, Tom Wonke, which is now the director of Fluid Power Consortium.
Yeah.
Also served as an advisor back then, and also a faculty member from the ME department, Dr. Vince Prantle. So I have served as an advisor since 2017. So typically we attend the event, and we select about 5 to 6 students to participate in the event as part of their senior project or capstone project.
Right.
Throughout the years, MSOE has been able to win several awards through that competition. However, up to this point, we haven't been able to become the overall get the overall competition award.
It will come someday, I'm sure. So
Yeah. So every year we look forward to being number one. But it's always exciting to participate in and to see all the different designs
yeah.
that different universities come up with.
Yeah, we are in the middle of. In fact, we've just launched our season of vehicle challenge competition. We have a record number of 23 universities participating this year, and
Wow.
I just put 23 different reviews on my calendar to review all
Awesome.
those designs and projects later in the year as those get developed. As you said, it's exciting to watch. I think one of the things that's unique about it is, MSOE has a lot of hands-on activities built into its curriculum, but for a lot of the other schools, this is like the only hands-on experience they get with fluid power. They're actually designing and actually building working fluid power systems with real fluid power products, and then they have to compete their bikes or their vehicles, if you will, in this competition. So I would imagine that the students on the campus get really jazzed about the forces that they're working with when it comes to hydraulic systems?
Yes, they really do. I mean, they really get excited about working. There was one year where I wasn't able to participate in the Fluid Power Challenge, and I received a lot of requests from students, and since then I've been actively participating in the Fluid Power Challenge because there's just such a huge demand from students. They find it really exciting, and then they get to use their technical skills in practice, really what they have been learning throughout in their classes, and to put it together and to essentially come up with a vehicle that they have created on their own.
That's great. Well, we've reached the point where we need to take a quick break in our show so that we can provide an update to our listeners on other opportunities in the fluid power industry space. So we'll be right back to our conversation with Luis and Daniel after this short break. All right, we're back from that break. Again, I'm having a conversation with Luis Rodriguez and Daniel Williams, both of MSOE, both professors there, about fluid power education opportunities that exist on MSOE's campus. And I know there's another one that I think is relatively new. Maybe you guys can tell me more about it. It's the Pneumatic Senior Project that takes place at MSOE.
Yes, so it's a senior project that it started. It was introduced last year. So basically the purpose of the project, which we have coined Newman 2.0, and essentially is to design a humanoid torso to be used for STEM education and outreach. So we want to be able to use this to motivate youth and also to showcase what our students can do. So the project itself is not original. This project was inspired originally by the original Newman senior project that was created about 20 years ago.
Yeah.
And it was actually pretty impressive considering the time period. The advisor back then was Jack Slater, and it was very widely successful at MSOE. And it received feature in commercials.
Yeah.
And if you and there's still a YouTube video that you can find about Newman promoting MSOE.
Yeah. Well, maybe we'll find a link to that video and put it in the show notes so people can take a look. I remember hearing stories about Newman, frankly, showcasing and being premiered at the IFPI trade show some years ago, as you're describing. It's got kind of legendary status in the industry to a certain extent.
Yes, and I'm still amazed, but what were they able to achieve in just 1 year?
Yeah.
It was just completely amazing. Three students and their advisor in 1 year, and they were able to create such a great system. So since then, the Newman, the original Newman, has been dismantled. So we want to take the opportunity to kind of revamp the project and perhaps continue the legacy of the original Newman.
Will there be different groups of students working on different pieces of the new Newman? How's that going to work?
Yeah, so we're planning on. Well, we have two different separate senior projects that are working on Newman. So it's a collaboration between the electromechanical team, which is led by Dr. Mike Cook from the ME department, and I advised the pneumatic subsystem part of the project. We did start the project last year, but because of the COVID restrictions and all the difficulties, we're again, and also because of the complexity of the project, we're having to continue the project this year as well.
Yeah. Can you give us more a description of what some of those projects are going to be? You said there's an interface with the electromechanical side.
Yeah. So the Newman is not only going to be actuated by pneumatics, right? So that's one subsystem. So the neck and the head movement will be actuated by pneumatics. There also is going to be a wrist and also an arm that's actuated by pneumatics. The electromechanical system is going to consist of the motion of the eyes. Also, the other arm is going to be driven by actually DC motors. And there's also a wrist that they're working on. So
right.
Half of the robot is going to be pneumatics, and the other half is going to be electromechanical, which is it's a little different from the original Newman, which was mostly pneumatically
all
actuated.
pneumatic. What about the control system on it? Is it electronic, I'm assuming?
Yes. So the whole control system will be electronic.
Yeah.
We needed to do sample sensors and provide electronic signals to the different actuators. So yeah, so that's going to be all electronic.
It sounds like very much the real world of fluid power today, where you're hybridizing all three of those technologies. The fluid power, in this case pneumatics, the electronic control of that, and then interfacing with electrical and electromechanical actuation devices as well. It sounds complex.
Yes, it is, but it's also fun, and I think the students really like the challenge. It also showcases the two different technologies, right? In the pneumatics versus electromechanical actuation. So we're pretty excited about it.
Have you gotten, so this is just up and running now this school year? We're just a few months into the school year, right?
Yes, exactly.
Yeah.
So this project will continue until the spring. Hopefully by then we'll have a prototype of the system. I'm hoping we'll have some motion, but it's possible that we might need another iteration to really get everything going.
Well, I know that, I think it was Dan who said something earlier about the elective, the fluid power elective at MSOE. And does this connect to that? Is that part of that class, or how does that work?
So being an elective, we sometimes have some intersection between those students and others that just take the elective, but there's not a direct required correlation between the elective and these projects. However, most of the students involved in these types of projects are interested in taking the elective if they can get into it. We have about 25 to 30 students taking it every year, and comes from a variety of students. But like I said, most of the students that are involved in one or more of the fluid power projects, either senior design projects or like the Fluid Power Club, have a direct interest in taking that class. It's an upper level class, so it's limited to seniors and juniors.
And yeah, I'd be curious in hearing a more detailed description of what students experience in that class, because as I understand it, it's unfortunately, from my point of view, fairly unique when you compare MSOE to other universities to actually have a dedicated fluid power class, right? So tell us more about that.
Yeah, and the class is definitely hydraulics, and we don't cover pneumatics at this time. And I'm hoping that in the future we could have a pneumatics class that would be parallel to it. But because of my background at John Deere, it's been the bias that I started with on it. And so we do a lot of circuit analysis, starting with the basics that they learn in fluid mechanics, and then extending it in to understanding how to match directional control valves and actuators, both cylinders and motors. Also, we talk about hydrostatic transmissions. And again, you can probably sense from the list that it's somewhat biased towards my off-highway experience,
sure,
but it's not limited to that. And then some of the exposure to components, accumulators, and applications of accumulators, and and just the whole idea of the different types of pump technologies that are out there for energy conservation and power management and things like that.
That's great. Yeah, it sounds like a lot of very useful content, especially for someone who wants to be a fluid power engineer. Where in a student's cycle do they usually take that class? Is that a junior level or a senior level?
So juniors can take it, but usually, oftentimes it's full by the time the juniors register, because the seniors get first crack at it. And so, like right now, we've just registered for the winter term to have this class. And so I'm guessing I didn't check, but I'm guessing it's full of seniors, and I actually have 34 people registered for it this time around. So
That's
it's
great.
a large class.
Yeah. Why do you think it's so popular? If I can ask a loaded question.
Yeah, well, we have a lot of students that have a really practical view of their engineering education, and that's partly why they're at MSOE, I'm assuming.
Yeah.
And so it also is a function of the fact that they all, if they're seniors, they've just come out of automatic controls class in the fall term. And since we do these experiments in the automatic controls class, we have to give them at least the basic exposure to the fundamentals of fluid power circuits. And they either like it or don't like it after that. And since we have such a large number of students that are taking the automatic controls class, it's not difficult at all to get this many students that are interested in fluid power and the understanding of the applications that they can get into, especially given the elements that Dr. Rodriguez talked about with all the combination of electromechanical and electronics and hydromechanical.
Yeah. What kind of, there must be a lot of hands-on in that class, I'm going to assume, using the labs and the other resources that you have there.
Yeah, well, the hands-on they get already in automatic controls class, because we have them do electronic controls, as I said before, of speed control circuits, where they explore the elements of proportional and proportional plus integral control and see the nature of saturations and things like that. And then they also do position control in that automatic controls class, where they are exposed to overlapped valves versus critically lapped valves, and kind of get an eye-opening exposure to what it means to have a dead zone and how that affects the controls. And so they get a really good hands-on exposure to that. Now, when they get to the fluid power circuits class, at this point, it's all analytical. When we go to semesters, we're hoping to, I plan to make that a combined lecture/lab class,
right,
and start to let them really get some hands-on exposure to doing some laboratory experiments, characterizing directional control valves, for example.
That's great. It sounds like it's a great track, for students who want to move into that space. It's a unique opportunity. As I said, it's unique in a lot of, you won't find that in a lot of other universities.
Yeah, I didn't have it when I went.
Yeah, I was going to ask you about that, Dan, as well. That when you went to John Deere, was that your first exposure really to fluid power? I mean, that was after your PhD, you said, right?
Yeah, and for the most part it was. If I look back, I had a co-op position at the steel mills near Gary, Indiana, for 7 months, and I did get exposed to fluid power at that point, but I was totally clueless, and it was a good experience looking back at it. But I actually have more probably comical stories for my students from that time than I have actually informative ones.
That's great.
But yeah, I didn't learn anything about fluid power analysis until on the job at John Deere.
Well, as you guys know, that is one of the things that we're trying to solve at NFPA. We're trying to provide as much support as we can to get more and more of that fluid power instruction in great schools like MSOE. So you guys are certainly on the cutting edge, and we appreciate that. As we wrap up here, I'm wondering if you guys can look into your crystal balls and tell us a little bit about what you see coming next on campus for fluid power. Is this going to continue to grow and expand? What are your thoughts on that?
Yeah, I believe so. I think MSOE has always been a fluid power leader in education. So I foresee that in the future, yes, fluid power will continue to be a big part of MSOE. We definitely are committed to fluid power education, and I foresee that in the future there'll probably be an elective that focuses on pneumatics, either its own class or combining it with the current classes that we have. For instance, introducing pneumatic experiments into our control systems class, or introducing pneumatics into a robotics elective class.
That's great. And Dan, what are your
Yes,
thoughts?
and as I mentioned before, I hope to we're going to transition to semesters in one more year. There's one more year before that, as in quarters, and as we switch to semesters, we can reconfigure our courses. So that's when I plan to make it my hydraulic circuits class a lab-based class. And we also have another elective that I do currently that involves simulation, which is the background that I had at John Deere.
Mm-hmm.
And we basically include some hydraulics simulation projects, way on the other end, away from hands-on, but into Simulink modeling and things like that. And these courses have an opportunity to grow and continue to involve students in hydraulics as well.
That's great. Those sounds like exciting developments on campus, and we'll look forward to seeing more and more students get involved and hopefully finding their way into positions in the fluid power industry.
Definitely.
So that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Drs. Luis Rodriguez and Daniel Williams, who have been my guest on this episode. If you'd like to connect with them directly, you can do that via their email addresses, and we're going to put links to those addresses in the show notes for this episode. If you're interested in learning more about NFPA's Power Partner University program that we've talked about here, you can log on to nfpa.com and check out our educator resources. We'd love to get more and more schools involved in this program, as I said, and really grow the number of activities, fluid power education activities that are taking place on these campuses. Remember, if you like our podcast, please remember to follow us on Twitter. You can find us there at the NFPA. And make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. Also, to see the latest fluid power technology and learn from industry experts, you can make your plans to attend IFPE, the International Fluid Power Exposition. Our next show will be March 2023 in Las Vegas, Nevada. For more information, visit ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. We are produced by Maddie Parise, NFPA's Communications Manager, and I'm your host, Eric Lenke, reminding you to join us next time in the forum.